everyone, my name is Kristen and I'll be your teacher on camera today. Behind the scenes, we also have some amazing other teachers. We have Rohini and Paul who will be working with you in the Q&A and the public chat down below. And you might see a little bit of Dan as well. So let me know that you can see and hear me by saying hi right down here. I see some names that I recognize. Hi Nicole, hey Luke, Simona, Molly, Austin, we have Charmaine. We have a good group today. So before we kick this off, hey Fong, before we kick this off, let me know, how did full length 1 go overall? How did it go overall? Nicole says not bad. Better than diagnostic. Austin, that's fantastic. Luke improved as well. So I'll tell you that I kind of see a little bit of everything. Molly said she stayed the same. I will be honest and tell you that when I took my first full length, when I was taking a Kaplan class forever ago, it seems like, my first full length score actually went down below my diagnostic score. It was very disappointing. I thought that was the end of the road and that I would never improve from there, but you will. So if you're feeling frustrated that your score stayed the same, that you went down, or you went up only a tiny bit, that's totally normal. Yeah, Nicole, absolutely. I saw a pretty big increase. Of course, I took the old version of the test. So I went from about an 18, I want to say, on my diagnostic to above 90th percentile. So don't get stressed out about where you're at right now. I know a lot of you you can't help it, right? You're like, I'm not close to 500 yet. I want to be at a 510. Don't worry about it. We got to practice these strategies. So a lot of reasons that your score might not be jumping up a ton. Remember, you haven't seen all the content yet. You have lots more practice to do. In addition to that, we've taught you a ton of new strategies. Now, these new strategies are fantastic once you've practiced them and they become second nature, but a lot of them can slow you down. And even worse than that, if they're not second nature, what tends to happen when you actually take a full-length practice test? What happened to you guys? Totally, Luke, they went out the window, right? That happened to me as well. I'd be like, okay, supposed to outline the passage. Then I'd dive in, I would forget to scan the section, just dive into the first passage, totally forget to triage, forget what I was doing, highlight everything. It was a mess. Okay, we have to keep practicing these things so that they become second nature. We don't worry about them anymore. My favorite analogy for this is driving a stick shift. Does anyone here drive a stick shift? I'm terrible at it still. I'm just awful. Nicole, no. Okay, not on the regular. So has anyone ever driven a stick shift? Have you tried it before? Yeah, okay, it seems crazy hard at first. If you don't do it on the regular, it seems like there's a million things going on. Am I right? Or is it just me? I know it's not just me. It's hard at first. It seems like there's 10 things you got to do at the same time. Well, I can guarantee you that people who drive a stick shift all the time can do it like it's nothing. It just feels like driving a car to them. Short legs, long arms, Luke. That's tough. So the point is that we have to keep practicing until these things become second nature and we no longer have to think about them. So we're going to keep practicing that, but I don't want anyone to feel frustrated about their full-length score at this point. I will also tell you, if you have not attended channel before, you're going to want to download the student PDF to follow along for tonight. I know you'll have seen these passages and questions before, but just so you have them for reference there. In addition, if you haven't attended one of the full-length or diagnostic reviews before, we have pre-selected some questions we want to go over, and this isn't really an opportunity to go over all of the content and all of the questions. It's to give you kind of a new look at how to handle strategy in certain types of passages and certain types of questions, and we'll see some content here and there. I will remind you that if you go onto your syllabus, you will find full answers and explanations to every question, which hopefully you're going through and reviewing on your own, making those why I missed it sheets. Now with that, let's go ahead and dive in because we got lots of good stuff to talk about. So in this episode, we're going to talk about managing the clock. How many of you were slaves to the clock throughout this? How many of you just looked at that clock constantly? It's probably not a good feeling when you look at it. Nicole says, yeah, Taylor tried not to, so that's good. Cars was probably the hardest section for you guys on timing. Some of the others may not have been too bad. What you will know is that on the science passages, they get super, super detailed. It's really easy to get sucked in, but you're just going to see that clock start ticking away. So we need to figure out how long we should really be spending on those details. We're also going to spend quite a bit of time looking at amino acids specifically, because there were some questions on here where we need to know about them in order to get questions correct, but we're also going to figure out how to use strategy if you don't quite have every single structure memorized. So let's dive in first here with managing the clock. All right, so Kaplan strategies. We know they're effective, the teachers here, because we've all used them. We're convincing that you're effective by having you put them into practice and showing you your score is going to increase once you get comfortable with them. Now, passage outlining, it's not the end-all be-all, right? It's a tool to allow us to get more points and get more points quickly. Now, it's easy to spend 5 minutes reading. It's easy, right? There's a lot of detail in there. You want to go through and figure out what everything says, try and figure out how all the pieces fit together. If you spend 5 minutes reading, you're only going to get 3 minutes on average for the questions associated with the science passage. We're going to need more time than that, so let's figure out how to utilize our time wisely, reading strategically to find the main idea of each paragraph so that we can throw it into that outline and come back to it later if we need it. So we're going to start off here practicing. I'm going to let you refamiliarize yourself with what you're seeing here. I'll give you about, this is short, about 20 seconds, and I'll just pause myself here. Read this paragraph and type down below for me what you would put as your label in your passage outline. Go ahead. All right, hop back in here and go ahead and tell me down below what you would put as your label. And I like what I'm seeing. Nicole has half-life of C14, Luke production constant, Taylor production half-life. We're all on the same page here. Love it, right? It's about carbon-14 production and decay. Now, if you're someone who really likes to keep track of reactions, you might have put something more like this. However, if this didn't come super quickly to you, this is not something we'd want to spend time writing out. This is something if we need more information on, we could come back here. This is just something that if you know quickly what this reaction looks like, you might jot it down. All right, let's try another one. I'm going to give you a little bit longer, about 30 seconds for this one. And when we get back, we're going to talk about what's important here and what is not. So go ahead and refamiliarize yourself with this paragraph from passage 7. All right, come back to me and tell me what is important here. I like that you guys are staying big picture. So it's about B12, it's about these pathways. Now, how many of you the first time through got kind of sucked into this detail? Be honest, it happens. Happens to the best of us. Anyone have that problem here? Austin, yeah, there's a lot of detail in here, right? Especially kind of towards the end. We get in here, we get tetrahydrofolate, we get N5N10, we get deoxyuretylate, we got dihydrofolate. There's so many names. Yeah, Taylor says I definitely read it all. Now, scanning it all, that's a good plan. Reading it all and trying to understand every single pathway at this point and understand all these terms and how they're related to each other, not a good use of our time. This is one of those paragraphs. We want to figure out the big picture and quickly get to those questions. Luke, absolutely. we're probably not even going to be asked about it. But if we are, our passage outline is going to tell us exactly where we need to go. So these are the kind of paragraphs that it's real easy to get sucked into. We have to be smarter than the test maker and keep on rolling. So here we have another one. This one's a little bit longer, so we'll actually put up the clock for this one so that you guys can kind of track your time now that you have a little bit of practice. We'll give you a full minute, but what I want you to do, when you're done, tell us done down below, and then type your passage outline. I want to see how quickly you can get through this and still figure out what this is about. So best of luck. We'll see you back here in 60 seconds. All right, gang, some of you finished a little bit early. Some of you finished right on the button. Now, what was this paragraph about? There's a lot of detail in here again. Lots and lots of it. Luke says how pressure affects weight. All right. What else do you guys get here? Pressure of gut tissue, arterial versus venous, balance between arterial and venous pressure, measuring pressure with flow. Now, what does this kind of sound like? You guys are describing what they're doing overall, but what do you get throughout this paragraph? What are you getting throughout the paragraph? Is it giving you steps on how to accomplish something? When you get steps on how to accomplish something, what is that typically called? How do we talk about that when we're dealing with experiments? Yeah, our procedure, our methods. All right, now you guys definitely pulled out the big picture ideas here, which is perfect. But this is another prime example of a paragraph that could be really tempting to try and jot down those steps, to make note of them. But these steps are simply telling us how we're going to go about this, and they're describing what we're seeing in figure 2. Now, if a question asks about it, that would be the time to come back here and kind of map out the flow of how this is handled in this paragraph. But initially, we should probably be able to get through this in less than a minute, quickly noticing that these are methods. If I need detailed steps, I will come back to this paragraph. Now, in this case, there actually is a question on this. So now that a question is on this, I'm giving you free rein to go back to that paragraph, figure out what you need. So let's take a look at the question real quick together, and then I'm going to let you loose to try it now that you know how to approach it. So this question says, during an execution of method 2 from the passage, you know exactly where to go. Assume that a mass M of 0.2 kilograms is placed 25 centimeters to the right of the fulcrum. A section of gut initially weighing 0.1 kilograms is placed 50 centimeters to the left of the fulcrum. During the experiment, the mass is seen to descend. In order to maintain the balance level, the following actions should be taken. Okay, so we're going to have to go back here and figure out what we need to do in order to maintain this balance here. So the methods were given to you in that paragraph. You're going to have to go back and figure out exactly what they are. So let me go ahead and bring up this paragraph again. I want you to kind of go through here and figure out how these items are related to each other. So I'm going to give you about 30 seconds to do this. So this should be a good way to kind of execute our plan here and start to make a prediction so we can answer this question quickly. So 30 seconds on the clock. figure out what our pattern and our flow is here, and we'll be back to discuss together. All right, let's come back and walk through this together now. So you guys tell me, if we see a decrease in arterial pressure, what else do we see a decrease in? You see that right here. The arterial pressure is then decreased. Yeah, so then we see a change in hydrostatic pressure. We then see an increase in absorption of fluid, which shows us a decrease in weight, which Nicole and Luke point out here. So we know the opposite trend is also going to be true. If we get an increase in arterial pressure, we'll see an increase in capillary pressure, a decrease in absorption of fluid, and an increase in weight. Now that we know this flow here, we can quickly and efficiently get an answer to this question. So I'm going to go ahead and bring a poll on screen, and you can get your answers in for me. Get those answers in. And check that out. I'm going to go ahead and broadcast. About 70% of us here are absolutely correct. In order to maintain the balance level, the following action should be taken. The venous pressure should be increased. So we're using the pattern we learned from that paragraph, but we didn't spend a lot of time on that paragraph until the question told us to. So awesome job here. Let's keep rolling through. Let's take a look at another question that's dealing with kind of a similar concept. The human head weighs 4.8 kilograms and its center of mass is 1.8 centimeters in front of the spinal column joint. If the trapezius muscle inserts 1.1 centimeter behind the spinal cord joint, how much downward force does it need to exert in order to maintain equilibrium? What is this question really driving at? What are we getting at here? Nicole, well, I'm glad we're going to talk about it together. So Molly says we could be looking at some torques, right? Because we're dealing with something that we want to keep in equilibrium. Now, some of you might be really, really strong with kind of spatial processing, but how many of you can really visualize this in your head? I know I cannot. This is a tough one to set up. No, so what should we do? How should we handle this? Taylor, draw it. Absolutely. So take a quick second and kind of draw this out, and I'll show you what it looks like here after you give it a shot. As Rohini says here, pictures on the MCAT will be your best friend. They're super helpful if we're trying to figure out what a question is really asking us. All right, so hopefully you've kind of jotted down an idea. So this is kind of what we're looking at, right? We have a fulcrum in the middle. We have a weight on one side that's placed 1.8 centimeters away. We have another one on the left side placed 1.1 centimeters away. Well, what do we know has to be true here? Without doing too much calculation, what do we know has got to be true? So Luke's saying we can say that this weight over here is going to have to be what? going to have to be less than, equal to, greater than this over here. Yeah, absolutely. Because D1 is less than D2, so we're calling this D1, we're calling 1.8 D2, then we know F1, which is our X, has to be greater than F2. Now, does that help us eliminate it all? Can we get rid of anything here? Yeah, it sure does. Let's get rid of answer choices A and B. Okay, so we have 77 and 100. Now, we could do the math, but we could be smarter than that. What could we do here? What could we do here? Charmaine says we could test one. We could do that. And what do we notice about answer choice D? What do we notice about answer choice D? Charmaine says it's too big. Let's talk about why that might be true. So answer choice D is exactly twice F2, right? It's double that of the head, says Nicole, and that's absolutely right. Well, because D2 is less than twice D1, we know that F1 must be less than twice F2, right? Because this equation here is F1D1 equals F2D2. So what we're saying here is that it's not possible for answer choice D to be correct, which leaves us with only one possibility. Now, if you're super quick with math with the fly, you might be able to do this relatively quickly. But avoid doing math whenever possible because it's going to slow you down. Let's try and eliminate answer choices and just plug and chug when we absolutely have to. All right, let's keep rolling here. And in the second part of today's lesson, we're going to focus primarily on amino acids. Now, how many of you know the 21 amino acids and their structures and their abbreviations and their abbreviations of single letter? That'd be awesome if you do. Molly says I used to. Yep. Luke, 75%. That's fantastic. Okay, flashcards, Nicole. That's on the right track. So flashcards, quick sheets, these are the way to learn these. You can even take a dry erase marker and start drawing them on your mirror. So when you're getting ready in the morning, guys, if you're shaving, girls, if you're doing your hair, whatever you do, be looking at those diagrams while you're getting ready. The more you see them, the better. All right. So let's first take a look in a figure and see where we're looking to determine what amino acid we're dealing with. So you tell me on the far left here, what part of this structure am I looking at to determine what amino acid I have? On the far left over here. Yeah, I'm looking for the side chain. Well, just a quick reminder, how do I figure out where the side chain is? Where's that side chain going to be? Yeah, Molly, very nice. So I'm looking for the part between the carbonyl and the amine group, okay? So when I'm looking at this first one, what is it? The one I just had in red right here. I'll bring it back up. What is that one? Let's see if you guys know. We got two guesses. Let me see if anyone else wants to weigh in here. Cole says, maybe that sounds pretty good. All right, so right there is where we're looking, and sure enough, that is histidine, and I'll show you kind of a chart of all of these in a minute so you can get more comfortable with grouping them, which is something we definitely want to do with these. Try and group them into similar structures. All right, so let's look at our second one. So again, I'm looking between the NH and the carbonyl. What do I see down here? All right, Luke and Molly are saying serine, and that's absolutely right. Killing it. All right, let's look at a third. This one's a bit longer up here. Again, we're still looking between our NH and our carbonyl. So we're looking at what's attached right here. See if anyone else wants to weigh in. Nicole says glutamine. All right, so Molly's recognizing, I can't quite remember how long the chain is, but I'm either looking at asparagine or glutamine. That's absolutely a good way to think of this. You've narrowed it down, and it is indeed glutamine. All right, what about our fourth one? Huh. I'm supposed to be looking right here. Interesting. There's nothing there. Yes, absolutely, glycine, probably the easiest one. The simplest one, glycine is a good one to remember, and this is going to help you at least with elimination. All right, so our fifth and final here, what are we dealing with? What do we got as our fifth one in this chain? Man, you guys are pretty good at these. You do know most of them already. Nicole and Molly, you absolutely nailed it. We're dealing with threonine. So getting comfortable with these is going to be really important because you know this is going to get you points. All right, so you also, other than just recognizing the structures, you're also going to want to be familiar with the three-letter abbreviation. We also need to be familiar with the one-letter abbreviation. So go ahead and tell me, what's our one-letter abbreviation for histidine? Yeah, H, absolutely. That one's not so bad. Serene's an S. Glutamine. What about glutamine? This one's kind of an oddball. What's glutamine? Ooh, I've stumped you on this one. Glutamine is actually Q. So this is kind of our standout crazy one here. The others make sense. Now, if you ever get confused, there's quite a few G's. Which one is G? Glycine is our simplest, so it gets the letter G. Threonine gets our T. Glutamine here, our kind of cool one that gets the letter Q. All right, so there are a lot of structures to memorize, and that is something that we're going to have to do. But grouping them together is going to be a really helpful way to start to look at these properties, another really common thing to be tested. So in your book, you'll see them grouped into kind of different properties. We might be looking at hydrophilic versus hydrophobic. We might look at acidic versus basic. We might look at ones that have aromatics attached to them and ones that don't. So I'm going to show you another figure which kind of has all of these in one place, and then we'll go back to the slide on screen here. This is just a wiki image of the amino acids, so if you want to pull it up, you can easily do that too. So you see here on screen them broken down up here with A. You got amino acids with electrically charged side chains. You have ones with positive charges on them, and you have our acids, aspartic acid and glutamic acid, glutamine and aspartame, that have negative charges on those oxygens. Then in B down here, you have amino acids with polar uncharged side chains. Then D, we'll skip C for a minute. D, we have all of our hydrophobics. Does anyone have a good mnemonic to remember the hydrophobics? Yes, Luke, very nice. So when we're talking about these, we're dealing with everything that we're seeing down here in the D group. And we're also seeing glycine and proline added in. And if we look at all of those letters, you are absolutely correct that our great mnemonic to help us remember all of the hydrophobics, family videos RPG. That's going to help you remember them. Now, everything that is not one of these is going to be what? Family videos RPG describes the hydrophobics. What is everything else? Hydrophilic, so it does like to be on the outside. Very important to understand these properties and then what that means when we're actually talking about these amino acids. So family videos, RPG, describes hydrophilic, which likes to be on the inside. So let's take that piece of information and score ourselves some points. We just covered this, and I know that you have a pretty good idea of what you're dealing with in these structures. So we're going to put 30 seconds on the clock. We'll actually pull up a timer this time so you can see it count down. I'll pull the poll back on screen, and I want you to attack number 30 again based on what we just discussed. All right, gang, go ahead and get your answers in. Then we're going to walk through this strategically, how we would attack this together. All right, I'm going to close it up in 3, 2, and 1. Looks about like 50% of us here said answer choice D. Now, let's talk about what we're dealing with here. We're talking about tyrosine and phenylalanine. All right, well, to use our nifty mnemonic, we're going to have to know those letters. So where do those letters fall? Are they in Family Videos RPG? Do those fall in there? Take a look together. Are they in there? All right, so we got an F, phenylalanine. And where is tyrosine? Where is tyrosine? The ty part should stand out. Yeah, tyrosine is the Y. Okay, tyrosine is the Y. So if we're looking at these, we have the F and we have the Y. And these are both in our mnemonic for hydrophobics. Family Videos RPG. Now, if we're hydrophobic, where do we expect to find these guys? On the inside, absolutely. Hiding from the water, hydrophobic means water hating, whereas hydrophilic is water loving. So our correct answer here has got to be answer choice D, which about half of us got. So this is a great example of how knowing these letters is really going to help you, because we have nifty mnemonics that help us, but if we can't remember what the key letter is for each of our amino acids, it's not going to be quite as helpful. So Nicole says, what about the OH on tyrosine? Doesn't that make it polar? So if we're looking at these, we want to make sure we have them broken down according to what we're seeing here. Now, what you will see is that our electrically charged side chains, like aspartic acid and glutamic acid, we can see that negative charge up there, and we can see that those are definitely going to be polar. But when we're looking down at tyrosine, we're seeing both our OH group and our NH2 group, which is going to cause us to be uncharged and hydrophobic. So Molly, that's a great thing to point out though, okay? If we're missing stuff, then we got to figure out why that is, right? So we have our double bond O, our NH2, and then we have our OH at the bottom, but we have this aromatic ring down here. So when we're looking at these, we can kind of group these together as well. So we have our aromatics, phenylalanine, tyrosine, and tryptophan all in our hydrophobic side chains. Proline is in that as well. So the only aromatic that we're going to see, or at least a ring structure that we're not going to see included in those, is going to be what? What's our only ring structure that's not hydrophobic? So proline is considered in our Family Videos RPG. It's our histidine, absolutely. Our histidine up at the top here. I'm going to draw a little star next to it. Our histidine has a ring structure, but is not in our hydrophobic side chain groups. All right, so if we're missing stuff now, let's make sure we know exactly why that is, so that moving forward, we can make sure we have tricks to remember this stuff. All right, let's take a look at another one here. An overabundance of which of the following amino acids is most likely to result in symptoms similar to those seen in PKU? All right, PKU, is this something I can answer without a passage? Nah, this should be a direct trigger. I need to go back to the passage to get more information. All right, so let's go back and get that information. In the course of studying the disease, it was determined that symptoms of mental retardation were attributable to the increased phenylalanine concentration in some PKU patients. Now let's see how this relates. So the question again said an overabundance of which of the following amino acids is most likely to result in symptoms similar to those seen in PKU? So how can I really rephrase this question to make it a little bit easier? Yeah, absolutely. Which amino acids are going to be similar to phenylalanine? Now that we kind of know what we're looking for here, I'm going to go ahead and bring up the poll again. So let me do that now. And I'll even leave the structures up here. Don't look at them unless you absolutely have to. You're not going to get them untested, so get used to not using them. A couple more seconds. All right, I'm going to close it up in 3, 2, and 1. And I'll broadcast. About 85% of us here said answer choice C, which is absolutely correct. Again, we're looking for something similar to phenylalanine. So we should look down in kind of this bottom right here, remembering those hydrophobic side chains that have those rings in them. All right, so let's next keep rolling here. We're on a roll with these amino acid questions. Let's see if we can strategically answer question 34. Which of the following compounds is expected to have the highest boiling point? All right, well, how are we going to handle this? How are we going to handle this? We could think about hydrogen bonding. We could think about what kind of each looks like. All right, so let's start with our amino acids, glycine and valine. What do we know about those? Can we compare those directly to each other? Yeah, we already said that valine is going to be much more complex because glycine is our simplest. So do you think we could get rid of one of those? Can we get rid of one of those? Yeah, glycine is going to be pretty simple. It's going to have a lower molecular weight. And remember, when we're talking about boiling point, we can be talking about both intermolecular forces and molecular weight. So in the glycine versus valine, valine wins. All right, well, let's talk about urea versus water. Can we directly compare those? Can we compare those? Luke says urea is more complex. It's going to be bigger for sure. Absolutely like what I'm seeing. If we're comparing those two, we can get rid of water. Now we're down to 50-50 without spending a whole lot of time thinking about these. So if we're comparing valine and urea, now it's time to kind of compare those structures. So I'm going to bring them up on screen for you. I'm going to let you answer into our poll now that we've got it down to 50-50. Sure, odds I like much better than 25% chance. Go ahead and get those answers in. Get them in, get them in. All right, I'm going to go ahead and broadcast. We are exactly 50-50 on this. And you know, if you're in the 50% that didn't get it, that's absolutely okay because we at least eliminated 2 answer choices. So go ahead and tell me when we're looking at these two, left and right, which one's valine? Which one's valine? Yeah, left is valine. Left has a lot more going on than we see on the right. And because that is the case, our correct answer has to be valine. Higher molecular weight, it has everything the right side has, but more added to it. So again, if I increase the molecular weight, or if I increase the strength of the intermolecular forces, I'm going to see an increase in my boiling point. All right, we're coming close to the end here. Just a few more questions to take a look at. So in question 2, answer choices seem kind of long, question seems kind of long, so this may have been a triage type of question initially. But let's say we're kind of wrapping it up, we're coming to the end, we're coming back to those marked questions. Experimenters isolate a protein sample from a volunteer's blood plasma. They wish to identify whether the sample is entirely made up of glycine or if there are significant concentrations of other amino acids present. In order to do this, they can. How can I rephrase this question? It's a pretty long question, Tim. How can I rephrase this? Austin, I like where we're going with this. What's special about glycine, right? Because it's asking us here, we're trying to figure out if it's alone or not. So we want to know what is special about glycine. So you guys go ahead and tell me down there below, what can we predict here? What can we predict here? So Tadel and Zionli, hopefully I'm pronouncing that correctly. If I'm not, please let me know. You guys are saying, first off, that it's really simple. It just has that H there. And we're saying it's achiral, or another way of saying that is it's not aptically active. So use that prediction to go ahead and score a quick point here. Answer into that poll on screen. All right, I'm going to close it up here in 3, 2, and 1. I'm going to go ahead and broadcast. Check that out. 100% of us here saying answer choice B. 100% get pink stars. Awesome, awesome work. Not every amino acid question has to be stressful and challenging. Not every single one requires knowing every structure. So we can still gain points with some of our lower level knowledge on amino acids, and those are the types of questions that we want to get correct every time. So awesome job on question 2. Now let's take a look at our acid-base properties of amino acids. Now when we're looking at charged side chains, we saw these a bit earlier. We can either see positive charges or negative charges. So when we're down here dealing with aspartic acid and glutamic acid, of course we're going to see that negative charge showing up on that O. And then we see our positively charged side chains where we have our NH2s. So when we're looking at these, we're going to want to be familiar with pKa's of these. So our ionization of weak acids and bases are going to depend on the pKa and the pH of whatever solution we are in. So knowing some of the general pKa's of what we're dealing with is going to be helpful. You definitely don't have to memorize them for everything. But if we're looking at our carboxyls, we're looking at around 2. Our histidine side chain is going to be around 6. And our terminal amino groups are going to be that 9 to 10. Which makes sense. If we have that high oxygen charge, we're going to be more acidic. If we have that amine, we're going to be more basic. Now, if we did have to figure them out exactly and you did have to plug something in, they would have to give you more information, but you are going to want to be familiar with how to calculate the PIs here. So our PIs are just going to be the averages of our 2 groups that we're having, so you can do this for both acidic amino acids and our basic amino acids. Again, these are not values you have to have memorized for certain amino acids. You just want to be familiar with generally where these are going to fall on the acidic to basic spectrum. So let's take a look at a question and do some practice on this. The following titration curve would be expected from which of the following amino acids? Now first we need to take a look at this curve and see what we recognize. So go ahead and tell me, where do we see the equivalence points? What part of the curve is an equivalence point? Yeah, so we're going to talk about the flat part too, but the equivalence point is actually the middle of the vertical or the sloped part. So if we're looking here, we see 3 different equivalence points. Now, if we go to the flat part, what would we call the flat part? Right here. So these are going to be our buffer regions, but specifically we would call this the half equivalence point. Now, if we're dealing with these, we want to pay careful attention to where the pH falls in these regions. So in these regions in our buffer zone, we know we're dealing with Henderson-Hasselbalch, and we can say pH equals pKa. Now, our pKa's, of course, are going to fall if we just draw lines across to the horizontal to see where we're at. So we've got 2, 6, and 9. 2, 6, and 9. Am I going to be super acidic or super basic here? No, I'm not really extreme one way or the other, right? All right, so with that said, go ahead and take a look at these structures. For this one, I'm going to pull our poll over here. Go ahead and get your answers in. Because we're dealing with 2, 6, and 9, we want something that's going to be weakly acidic, but it's not going to be super acidic because it's 2, 6, and 9. All right, I like what I'm seeing for the most part here. I'm going to go ahead and broadcast. Looks like a majority here are saying answer choice B. Now, taking a quick look at A, what could we say about A? Is it acidic at all? No, we're dealing with valine here, not acidic. Now, answer choice B is histidine. And we said on our last slide, we want to be familiar with histidine, and we said that was around 6. So if we knew that, we knew B was right off the bat. Now, why are C and D wrong? How can we get rid of those? How can we get rid of those? Yeah, those have our negatives on them, so these are going to be too acidic. We're dealing with glutamic and aspartic acid, which are going to be our most acidic, and they would fall well below 6. Absolutely, too acidic, Taylor. All right, answer choice B is it. If you were able to do some elimination here, again, that's what we're looking for. We want to use strategy to start eliminating. So let's next take a look at question 1. Suppose that multiple newly created amino acids interact to build a small protein molecule. The primary structure of the protein is formed when? Okay, primary structure. What's primary structure again? What's our primary structure? Yeah, the order of amino acids. And how do amino acids get formed? How do amino acids get formed? Or how do they join together? They join together through a peptide bond. So we need to ask ourselves, how are peptide bonds formed? So I want you to ask yourself that question. Let's see how we do on this poll here. I'll just stay on camera for this one. Go ahead and get your answers in. All right, get them in. I like what I'm seeing. I'm going to close it up here in 3, 2, and 1. Looks like the majority here saying answer choice B, and a peptide bond formation is indeed a nucleophilic acyl substitution, which is described by answer choice B. The amino terminus of one amino acid attacks the carboxy terminus of another. We know that that C double bond O loves to be attacked. We're going to see that in so many different reactions. So awesome job on question 1. Again, there are going to be easier amino acid questions that aren't going to take memorizing all those structures, but let's put that on the list of things to know for testing. Now let's take a look at another question dealing with peptide bonds. Which of the following is not a characteristic associated with peptide bonds? Now what we might do here is look through our answer choices and eliminate things that we know are true. So let's take a look here and start with resonance. Do we have resonance in peptide bonds? We do have resonance. All right, so let's eliminate that from our list. Now, tell me this. What does resonance provide? Stability. So if I'm really stable, am I also going to be highly reactive? No, I'm not. So in this question, I don't even have to evaluate everything. By evaluating answer choice A and saying that's definitely true, I know B is going to be an opposite to that, and I can quickly get to my correct answer. I love it when it's fast like that. Don't get too caught up in these questions. Make sure you're going first for the things you do know and narrowing it down from there. Absolutely, Molly. We definitely wouldn't want all of them to be highly reactive. That would not be beneficial to us. Now let's take a look here at question 13. This is our last question for the evening, and it's a pretty long one here. When blood is donated, it is important that no active antibodies are transferred along with red blood cells. In order to accomplish this, a reducing agent, which breaks the disulfide bonds that maintain the quaternary structure of antibodies, is added to donated blood. This is effective because. Now you tell me, what pops out in this question stem as important to you? Yeah, breaking of disulfide bonds really pops out here as what's important. Now, when you see disulfide bond, what do you think? What comes to mind when you see disulfide bond? Yes, absolutely. I like what I'm seeing here. You guys are making good predictions already. So when we're thinking disulfide bond, we should be thinking oxidation. We should be thinking oxidation of two cysteines. Now with that, we already have a strong prediction in mind. We can wade through these answer choices and not get trapped by things that sound good. So go ahead and get your answers in on our final question for the night. Give me about 5 more seconds. And I'm going to close it up. Check that out. Oh, our poll got messed up. I hate when that happens. But I will tell you, I saw it and it was 100% for you guys. So this is a prime example of where we should not get sucked into answer choices. I guarantee you some of these would have just sounded good if you would have started reading them. So make strong predictions after you have a plan for the question. Another pink star to wrap it up tonight. You guys absolutely killed it. So I want to do just a quick reminder here of what you don't need to know, because I'm sure at this point you're feeling like there's a heck of a lot you need to know about amino acids. So the good news is you don't need to know essential versus non-essential, and you don't need to know the exact pK values. We kind of gave you the important ranges to be familiar with, that 2, 6, and 9. Now, you also don't have to know which codons code for which amino acid, with one exception. What do you need to know in terms of codons? Probably talked about it in molecular genetics too, if you've attended that already. Yeah, you're going to want to know those start and stop. So start specifically AUG codes for methionine. You want to be familiar with that. Now there are 3 stops. I would recommend knowing those as well. All right, so you also don't need to know the non-standard amino acids, so you just need to know the important ones that you need to know the structure and those properties. And of course, we're going to be grouping them together. Now, as a review of what we've done in our last 55 minutes, we talked about how we can see really detailed paragraphs that make us want to spend time reading them. We want to analyze every detail, we want to know every step, but we know this test doesn't give us unlimited time. We have to be very wise with where we spend our time, and particularly on the sciences, that's going to be on the questions, because so many times they're not using a passage at all. Those pseudo-discretes, you can't spend too much time on the passage and still get them correct. Now, we also spent quite a bit of time talking about amino acids because it is something that's relatively new here on this new version of the test. Some of you may not have had biochemistry, but this is something you can learn on your own. The depth in this area is not so significant that you have to have biochemistry to do well on this. So make sure you're making those flashcards, write on your mirror. Whatever you can do to help get yourself up to speed 100% on those amino acids are guaranteed to get you some points on testing. Now, with that, we are at the end of our Chem Phys review from full length 1. I would love it if you would stick around and join me for Psych Soc. We'll take about a 5-minute break and we will be back to dive into more. Great work on your first hour tonight. Hope to see you soon.